Hi everyone! Alright, so in this video, I'm going to go over convolution for discrete time systems. And so, what was that? Phantom signal. Okay, so the equation for a convolution for discrete systems is as follows. X of n convoluted with h of n, which is the impulse response. And so this is actually the sum of infinity, k to minus infinity to infinity of x sub k times h of n minus k, or the summation of k minus k of minus infinity to infinity of x n minus k times h of n. So k here is a lag, and n is the index of your point, if that makes sense. Index. And so this will be more clear when I do the example. Okay, so example. I'm going to draw two signals for you. And I'm trying to make it small so I have room to write it out. Two, x of n. This is n minus 2. 2, 4, 6. Okay, I'll zoom in. Okay, I guess I can't zoom anymore. Okay. Fix that. Okay. So, 0, 0, 2. And then at 1, it's also at 2. And then this is 1. And then the rest is 0. Okay. That's x of n. That's giving me OCD. Okay, I can't move it. Never mind. All right. Now let me draw your impulse response. So I'm going to do over here. Okay, so this one goes up to 3. This is h of n. This is n. Oh. Okay. Dang it. Okay, minus 2. 2, 4, 6, and 8. That's an ugly 8. 8. And 0, 0. This is at 3. This is also at 3. This is at 3. 3. And 3. And the rest are zeros. Up to 7. Okay. Let me try to fit both. Okay. So these are our two signals, right? So what do we need to do first? Let's look at the equation. I'm going to choose to use this equation since it's, for me, it'll be easier. Okay. And if you look, you can rewrite this equation as, let me move this a little higher. You rewrite this as the sum of k from minus infinity to infinity of x, pull out the n of minus n plus k times h of n. Yeah, okay. So, according to the new equation I wrote, first things first is you're going to flip x of n about the vertical axis. So let's do that. Okay, let me draw. This 2 and x of minus n. Okay, minus 2, minus 4, minus 6, and 2. So then we get the colors 0, 0, 2, 2, 1, and then zeros. Okay. And now you're going to multiply it, this function, with h of n after shifting it. So let me draw that out. Oops. Okay. Let me draw this line. Okay. Actually, maybe I should make it a different color. What's a good color? Do silver. Actually, just kidding. I'm going to use that one. Okay. And I'm going to try to make this match as best as possible. Okay, anyways. Let me just do the first couple. So, when you're shifting by k, what that means is that... Let me get my last one. Ooh. How am I going to fit this on the screen? Okay, let me try that. It means you're shifting x of n. Oh, dang it, I didn't get all of it. Okay, let me try getting all of it. By k. And k iterates by 1. So that means for k equals 1, I shift it over by 1 so that the two functions... Oh, no, don't change colors. Okay. So that the first point overlaps at 1. At that 1. Right? And then at k equals 1, which is right here. Whoops. Right here. So it overlaps by 1. And so now, for the next k, okay, work with me one note. For the next k, I'm actually going to shift it by 2. So that it's overlapping. Oh, no, 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 stop changing colors. Okay, get out. Okay. Ow. Oh, God. Okay, okay, okay. It's overlapping by these 2 points. So that's what it means. That's why k is called lag, because you're lagging. You're slowly overlapping the two functions, and it lags by that much. So I'm not going to draw it out because it's going to take a while, but I will draw a table so it's easier to keep track of. Let's go back to white. Okay. So all we need are these two. Yeah, okay. I'm going to make this a little shorter so I have more room to write my table. Okay. So this is n, and then this is going to be y of n. So at -2, that's 0 because you have 0 times 0. Okay, I guess I will move it every time. You have these 2 points multiplied, which is 0. Okay. Then for n at -1, same thing. It's 0, 0 times 0, 0. So at n equals 0, though, that's different. Excuse me. Sorry about that. Okay. At 0, however, oops, let me get rid of those circles. At 0, you have something different. What you have is what you have is 0 plus 0, these two first points. And then you actually have this, oops, this point overlapping with this point now. So it's plus 3 times 2. Oops. Let me draw that out. I'll draw out the first couple because it also helps me keep track. I thought it erased things. There. So this one is overlapping with that one. That is 0. That's multiplied by 0. And then the rest is being multiplied by 0 too. So this is where 3 times 2 comes from. And then the rest is multiplied by 0. Okay. I'm speed up a little because it's going to be a long video if I don't. Okay. So, I'm going to go back to pencil. The next one at 1 will be 3 times 2 plus 3 times 2 because of these two. And then at 2 will be 3 times 2 plus 3 times 2 plus 3 times 1. The next one is 3. That's the same. 3 times 2 plus 3 times 2 plus 3 times 1. And at 4, it's 3 times 2 plus 3 times 2 plus 3 times 1. Oh, those are some ugly 3s. And at 5, 3 times 2 plus 3 times 1. And then at 6, it's 3 times 1. Because this is 1 times the last overlapping. Yeah, okay. So, I'm not going to do it for every point, but you can do this on your own and double check with my work. But what ends up happening is that your y of n, where should I draw this? Will look like this. Let me change one of these colors to bronze. Let me see. Whoops. 3, 6, 9, 12, 15. This is y of n. This is n. So minus 2. Let me see. It goes up to 6, right? So 2, 4, 6. And I'm going to just put some extra points. Okay, so these were 0. The first one, n equals 1, n equals 1, n equals 0 is 6. Yep, 6. N equals 1 is 12. Maybe I should have simplified it. Oh well. N equals 2 is... what is that, 15? Yes, it is. 15. Oh, that's ugly. 15. 3 is also 15. N equals 4 is 15. N equals 5 is 9. N equals 6 is 3. It's a shorty. And then the rest is 0. Yeah. And that's how you do convolution for discrete signals, which is, it is very long, but once you get more practice, you'll figure out how to do it quicker. But yeah, that is it. Thanks for watching. See y'all next time.